Design of staircase. Let us first define the important terminologies about staircase and its parts and types of staircase. We will also be dealing with the important design considerations of designing a staircase based on Indian Standard Code IS 456. Now let's first define staircase. Staircase is a means by which you can access different levels or floors of a building, by which we mean vertical transportation. That is, if you want to move from one floor level to another, then we make use of staircase. You all might have seen staircase in different buildings and of different types and shapes and different geometric orientations, and about which we shall deal with very briefly. And broadly, we have staircases constructed out of reinforced cement concrete as well as steel. So here in our subject we shall deal with the design of reinforced cement concrete staircase. Now first let's discuss about the different parts of staircase. You see this figure? Here is shown the different types of staircase which we normally see: the waist slab type of staircase, the tread riser type of staircase, isolated tread slab type staircase. In all these cases we will find broadly there are two parts of the staircase. The first being the flight of steps. Here you see the inclined structural member, that is the flight of steps which contain steps or triangular elements which make up the whole of the inclined flight of steps. And you have the other component which is the horizontal surface, which we call by the name landing or landing slab. So broadly every staircase consists of flight of steps as well as landing slabs. Okay. The horizontal projection or the horizontal distance between the first and the last step of this flight of steps, we call it by the name going. So going is nothing but the horizontal distance measured from the first as well as the last step of this staircase. Okay. The remaining space we call it as landing. The horizontal distance we call it as the width of landing slab. And here you observe everywhere you have steps. In all the three types you have steps, and the steps are also defined using different terminologies. You see, the horizontal surface of a step we call by the name tread, and that is where we lay the foot. We step onto the surface of the step, and that surface we call it as tread. And the step will have a vertical surface as well, which we call by the name riser. So every step, every individual step in all kinds of staircase will have what is known as tread, which is the horizontal surface, and what is known as a riser, which is the vertical surface. And the width of the tread we call it by the name tread itself, represented by the letter T. And the height of the riser we call by the name rise, represented by the letter R. So every step in any kind of staircase we define them using the two terms tread as well as rise. Tread represents the horizontal projection and rise represents the vertical projection. Okay. And here the three kinds of staircases which you see, you call them by different names. One is the waist slab type. So waist slab type means the flight of steps will have a slab, an inclined slab of constant thickness T, and on top of the slab you construct steps which may be made up of concrete or brick. If it is made up of concrete, it may be casted monolithic with the waist slab itself, along with the waist slab itself, or if it is made up of bricks, then you cast the waist slab and on top of which you construct it using a masonry. And now coming to the tread riser type, here you don't have a waist slab as in the previous case. You merely construct the tread and rise are in the form of steps itself using the reinforced cement concrete. Okay, now you can have another type of staircase known as the isolated tread slab type, in which the landing slab and the tread of the steps, and each of these steps, you see, they are individual units, they are separate units, they are not cast monolithically, they are not cast as a whole, they are cast individually, they are separate elements. Okay, now let's discuss about the different types of stairs based on the geometric configuration. So the previous case was the type of staircase, and now it is the type of stairs. You observe the stairs will differ from one another based on their geometry configuration. The geometry configuration, you see here, there are 6 different types of stairs available which you normally encounter in real world. The straight stairs are the ones where you have a single flight in a particular direction, and in case of quarter turn stairs, you have a flight which turns by 90 degree, and in case of dog-legged stairs, you have 2 kinds of flights, one going this way and you have to turn, and you have a landing slab here. You turn by 90 degree first, and again you have to turn by 90 degrees. So overall you turn by 180 degree, and you have to climb the next flight of steps. Okay, and one thing to be kept in mind is that in case of dog-leg stairs, you don't have a open space between the 2 flights of steps, so it is very close to each other. Okay, now coming to the open well stairs, if in case of dog-leg stairs you have a space in open space in between the 2 flights, then you call it open well stairs as shown in this figure. So you have flights going all the way here, turning again and turning further 90 degrees, and you encounter a space here which you call it as the open geometric well. So this is known as the well of a staircase. So if you have a well, then you call it open well staircase. And the next type of staircase is a spiral staircase. You will be provided with a central post around which you have winders. We call these kind of steps as winders because the width of the step themselves will vary constantly from the outer side of the staircase to the inside. Okay, so we call them winders. So these steps will go all the way around the posts, and we call them spiral staircase. And the last one is the helicoidal stair. Helicoidal stair is mostly a kind of spiral staircase, but you don't have to turn by the 360 degree as you do here. It is just about you turn by some angle, then you call it helicoidal stairs. So now let us study how to design a staircase. So strictly we will be following the Codal procedures, and the basic stuff to be kept in mind is that staircase is basically a kind of a slab. We already discussed that staircase is composed of inclined flight of steps, and you have a base slab and a landing slab also. So basically the component which makes up a staircase is a slab, and you know the design of slabs, and that is exactly what you do here. The design of staircase is the same replica of how you design a one-way slab. Okay, so staircase is nothing but a one-way slab, and you just have to know how to design it. So that is exactly what we are going to do now. You just have to do some preliminary steps before you start the design. That is exactly what is meant by determining the geometric parameters. Unlike a one-way slab, a staircase is something of a different shape and a kind, and you need to determine its dimensions and other geometric configurations, and that is exactly what we mean by determining the geometric parameters. So what all are we going to determine first? What all geometric parameters are we going to find out? So first is that the staircase, as you know, is composed of different steps, and the steps are designated in terms of tread and rise. Okay, as shown here, there is a horizontal surface and a vertical surface also, and you know they are called by the names tread and rise. And if it is given in the question, you can very well take the values of tread and rise, and if it is not given in the question, you can assume it to be approximately equal to be 300 millimeter and approximately 155 and approximately 150 millimeter respectively. Now coming to the number of risers, you need to determine the number of risers in the entire staircase, and you may be given in the question the height between the floors. By height between the floors, please keep in mind that it is the surface to surface height. Okay, the distance is measured from the surface of the ground floor to the surface of the first floor, or it is from the surface of the first floor to the surface of the second floor. So based on what is given in the question, it is the surface to surface height. Okay, so that is known as height between floors divided by the rise value, which may be given in the question, or we have already assumed it to be approximately equal to 150 millimeter. So height between floors divided by rise will give you the number of risers in this entire staircase. And this condition should be essentially kept in mind. The number of risers in a flight should not exceed 12 numbers. That is, in a single flight, the maximum number of risers which you can provide is 12 numbers. Okay, so since you have found out the total number of risers in the staircase, you have to restrict the number of risers in a single flight to less than 12. Maximum you can have 12 numbers of risers. So if you have 20 risers in the entire staircase, then you can give only 12 risers in a single flight, and the remaining 8 risers may be provided in the second flight. Okay, so that is what should be done. And if you have found out the number of risers in a single flight, then you can find the number of treads in a single flight. So that is exactly given with the help of this equation, number of treads in a flight. So in this equation we mean for a single flight, the number of treads is equal to number of risers minus 1. Okay, so if you know the number of risers for a single flight, you subtract it. You subtract it. In that case, number of treads is obtained by subtracting 1 from number of risers. Okay, now it is important you know the width of the staircase also. Generally the width of the staircase is around 1.1 to 1.6 meters, and you may reduce it to not less than 0.85 meters. In residential buildings, normally you will find the width of the staircase, the width of the stairway is around 0.9 to 1.2 meters. Okay, and length of going, you see the length of going is what is shown here. The length of going, if you know if you know the value of tread of a single step, and you know the number of treads, in that case you just have to multiply tread with the number of treads to obtain the length of the going. Okay, now coming to the length of the landing. So going, you determine the length of going. Now you need to find the length of landing, or the width of landing. So that is marked here, that is shown here in the figure. So the width of landing is generally taken as the width of stair. Okay, so since you need this space throughout the entire staircase, you have to provide the width of the landing as the width of the staircase itself. Okay, now we have already found out the geometric parameters. Now we have to move on to the structural parameters. Now we are going to design the structure. So how should it be performed? The most important fact to be kept in mind is that the staircase is designed as a simply supported one-way slab of 1 meter width. So that is exactly what we do. We assume that the staircase is nothing but a one-way slab, and the same design procedures which we followed in case of one-way slab, we will do it here. We will replicate it here also, with the presumption that the width of the strip is 1 meter. So that is exactly, you know, that we have already done in case of one-way slab. 1 meter strip was chosen for the design, and you determine the value of steel for that particular strip, and you find the spacing between bars in that case, and you just have to apply the bars throughout the entire length of the slab. So that is exactly what we do here. We assume the strip to be equal to 1 meter wide, and you find AST, you find the spacing, and you apply the reinforcements throughout the entire width of the staircase. Okay. And before we proceed further, you just have to understand there are two cases of staircases in terms of structural parameters. Okay, so two cases have to be taken into consideration. That one case is that the landing slab span in the same direction of staircase. The landing slab may be in the same direction of staircase, or the landing slab can span perpendicular to the direction of staircase. So two cases should also be kept in mind, any one of which may come for the examination. So most probably the first case usually is found to come for the examination. Okay, so we just have a glance of it. So the landing slab spanning in the same direction of staircase. You just observe here, this is the flight of steps, and you have landing slabs here and here, and these landing slabs are spanning in the same direction. They are supported in the same direction of the flight of steps itself. Okay, so that is what is meant by landing slab spanning in the same direction of staircase. So here, as we already said, we just assume that this is a one-way slab. Okay, and this is the span. And what is that span? By span we mean effective span. And how do we measure effective span in this case? So according to the clause 33.1c of page 63, in this kind of staircase where the landing slab spans in the same direction of the staircase, we take the effective span of the staircase to be equal to the center to center distance between the beam or wall supports. So that is exactly what is shown here. You have support at both ends, which may be in the form of walls or beams, and the distance measured from the center of one support to the center of the other support, we call it effective span. So once you determine the effective span, then you just have to design it like a one-way slab. Okay, effective span you can find if you know the length of the going and length of landing. Okay, so which we have already discussed in the previous slide about determination of geometric parameters. So once these parameters are determined, you can easily find the effective span. Okay, and just give a thought here that we design it as a one-way slab. Okay, so it is essentially a waist slab. Okay, you see here there is a waist slab on top of which you have small triangular shaped steps. Okay, and since the waist slab behaves as a one-way slab, you have to provide the reinforcement at the bottom where the tension is likely to develop. Okay, but one thing to be kept in mind while you draw the reinforcement bars, or while you provide the reinforcement in the field also, you should provide reinforcements in the tension side from the waist slab, which goes into the landing slab, but to the top of it. Okay, it should go to the top of it and not directly bend it at this kink. Okay, at this junction you are not supposed to bend the reinforcement like this. This is wrong. This is a wrong practice of laying reinforcement. So that is about landing slab spanning in the same direction of staircase. Now you observe here you have a landing slab spanning transverse to the direction of staircase. You observe this figure. You have staircase here, the flight of steps here, and the landing slabs are not supported at the end supports, end walls or beams. Instead, they are supported on either sides like this, on here as well as here. Okay, they are not supported here at the ends. Okay, so the spanning of landing slab is perpendicular to the direction of flight of steps. Okay, the spanning of landing slab is perpendicular to the direction of flight of steps. And how to measure the effective span in this case is decided based on figure 17 in IS 456. You just refer to this clause 33.1b, page 63. Now once you have decided how your staircase is going to be, and you have determined the effective span of the staircase, which would be designed as a one-way slab itself. What you should do next, you have to calculate the loads. Why? Because you need to determine the moment to be resisted by the slab or the staircase. Okay, so for which you need to calculate the loads. And how are you going to do it? The loads are calculated separately for landings and going. The landings and going, you determine the loads separately. Okay. And now another thing to be kept in mind is that the steps are usually treated as triangular non-structural elements, because we call them non-structural because they do not have any structural function to perform. They do not add to the strength of the staircase. And it is the waste slab which is designed to resist the load effects on the staircase. So whatever load which comes over the staircase has to be resisted by this waste slab. Okay, so we are going to determine the thickness of the waste slab. We are going to design this waste slab and not the steps. Okay, now the waste slab thickness is determined from the limiting values of L/D ratios, as in case of one-way slabs. So we already studied in the design of one-way slabs where the depth of one-way slab was fixed based on the limiting L/D ratios. And that is exactly what we have to perform here to determine the thickness of the waste slab also. And whatever thickness we provide for the waste slab, the same thickness we will provide for the landing slab also. So the next important thing to be performed is that we have to calculate the loads on the staircase. So we have already said the loads are to be calculated separately for going as well as landing. So that is exactly what we are going to do. Since the configuration, the shape of the staircase is relatively complicated compared to the one-way slab, we have to know how we determine the self weight or the dead load of the staircase. So separately for going as well as landing, we are going to find it out. The self weight of the waste slab on going is equal to unit weight into width of slab strip into depth of slab. So usually in case of one-way slabs, we do only up to here, unit weight of concrete into width of the slab strip into depth of slab. But since waste slab is a inclined slab, we have to multiply it with the inclined length divided by tread. And how do we find the inclined length? From this figure, you know the dimensions of a step, the tread and rise of a step. The inclined length of that step can be determined using this equation, square root of t square plus r square. So once you know the inclined length, you substitute it here and you can find the self weight of the waste slab on going. Okay. Now you have to determine on landing the self weight of waste slab on landing. So the landing slab self weight is what is you are going to find out. So it is fairly easy. Unit weight of concrete into width of slab strip into depth of slab. The steps also contribute to the dead load of the staircase. So we have to find the self weight of the steps to be equal to unit weight of concrete into width of slab strip into average thickness of the strip. The average thickness of the step is taken as rise divided by 2. So you see this figure, this is a triangular element, step is a triangular element and rise is this much, and the thickness of the step varies from 0 to a maximum of equal to rise, and on an average you take it as rise divided by 2. Okay. So once you find these values, you can well determine the loads on the staircase, using which you can determine the moments. So this is exactly what you would get. You determine the landing loads separately and going loads separately, and once that is found out, you apply it on the staircase, which functions merely like a simply supported slab. Bending moment will be maximum where? At the midspan. So maximum bending moment that occurs at the midspan has to be found out. Okay. In case of one-way slabs for some simply supported conditions, we said that the maximum moment to be resisted was WL square by 8, but here it is not possible to use that equation because the loading is not uniform throughout the entire length of this slab. You have different loads separately on landing as well as goings. So the remaining procedures are the same. Since it is a one-way slab, you have to provide the distributor bars also, and the other steps like determining the value of tension steel main bars, finding the spacing, or determining the depth of neutral axis, all such procedures are the same as you do for one-way slabs. So now we shall solve the numerical examples.